In this video, let's solve this problem. Already in the previous video, I've given the definitions for beta gamma function and the relationship between beta and gamma function. So now let's solve this problem. So now I have to prove that this into this is pi by 2 root 2. So what we will do, we'll write the first one as I1, second one as I2, and we will multiply both at the end. So first we will solve this problem, integral 0 to infinity root y e power minus y square dy. Take this as a separate question. So I can write this as integral 0 to infinity. I'll write e power minus y square first. Root y is nothing but y power 1 by 2 dy. Now I'm going to check with the formula that suits this. So we have gamma of n two version. One is integral 0 to infinity. Let me write e power minus x power n minus 1 dx. This version is not going to help here because the power is e power minus x. So what is the second version? If I substitute x square, what I will get? Integral 0 to infinity e power minus t square. I think one more 2 will come, and then t power 2n minus 1 dt. So this matches. See here, everything is same. Correct? So the place of y I have t. So but what I should compare it, e power minus something square means I can use this formula. E power minus x means I can use this formula. So I'm not going to use this. I'm going to use the second version. So of course this 2 is not there. So what I can do, gamma of, which implies, I'll write this, gamma of n by 2 is equal to integral 0 to infinity e power minus t square t power 2n minus 1 dt. So this is gamma of n by 2. Now I'm comparing the place of e power minus, because 2 is not there, so I'm pushing this 2 down. That's it. This I'm sending it down. E power minus y square, e power minus t square. So in the place of 2n minus 1, what I have in my question, 1 by 2 if I compare. Correct? Other things are exactly same. So gamma of, which implies I1 I can write. I1 is equal to gamma of n by 2. So what is this n? What is this n? How to find? They have given the clue. In the place of 2n minus 1, what I have? 1 by 2. So 2n is 1 by 2 plus 1, which is 3 by 2. Therefore n is 2n is 3 by 2, which implies n is 3 by 4. So in this problem, I1 is gamma of n. Here in this problem, gamma of n is 3 by 4 by 2. Or 1 into 1 by 2, you can write. This, let it be I1, let it be equation, say 2. Because your formula, this formula I'm not using, so I'm striking it off. This formula I'll use it for the second one also. I'll name this equation 1, which is the formula. Okay. So now I'm going to write the second half of the question, which is I2. And finally I'll multiply both. So I2 is integral 0 to infinity e power minus y square by root y dy. This is the question they have given for the second half, which is this. Okay. So it is this only we are going to write. I've written this as I2. Same story. How will I rewrite it? Integral 0 to infinity e power minus y square. Denominator, it is y power 1 by 2. If it travels to the numerator, it is y power minus 1 by 2 dy. So I am comparing with formula. Already we have derived, right? 2 is not there. Gamma of n by 2 is integral 0 to infinity e power minus, if you want you can write t square, or you can write y square itself, y power 2n minus 1 dy. In the place of y we have t. I am rewriting same equation 1. Here t dt. Everything I change it to y, so it's easy for you to compare. So this is same. In the place of 2n minus 1, now what I have? Minus 1 by 2. So your I2 is also same thing, gamma of n by 2. Your I1 also, you remember you wrote gamma of n by 2. But what is n? In this second half, 2n minus 1 is nothing but, see here, 2n minus 1 is nothing but minus 1 by 2. Can you see this? This fellow, 2n minus 1 is minus 1 by 2, which implies 2n is this, if it goes to the other side, plus 1. So 1 minus 1 by 2. 2n is 1 by 2. Therefore, n is equal to 1 by 4. So what is your I2? Gamma of 1 by 4 by 2, or I can write it as 1 by 2. In your question, we have two terms, which is I is equal to I1 into I2. Your first answer is gamma of 3 by 4 into 1 by 2. Your second answer is here, gamma of 1 by 4 into 1 by 2. So 1 by 2 into 1 by 2 will become 1 by 4. And we are using the formula gamma of 1 by 4 into 3 by 4 as pi root 2. How we got this formula that gamma of 1 by 4 into gamma of 3 by 4 is equal to pi root 2 by using duplication formula. And in duplication formula, you will substitute m as 1 by 4 in your duplication formula. So what is your duplication formula? Which formula I will substitute? Let me. Root pi into gamma of 2m is equal to 2 power 2m minus 1 into gamma of m into gamma of m plus 1 by 2. So this is for your extra knowledge. You can take this as a direct formula. Gamma 4 into gamma of 3 by 4 is this. So what they have asked to prove? They have asked to prove is pi by 2 root 2. So no harm. It is the same, right? Just simplification is left over. Pi root 2. 4 I can write it as 2 into 2. Let me write down here. Pi root 2 by 2 into 2. This 2 I can write it as denominator again root 2 into root 2. 1, 2 I will keep as it is. This and this get cancelled. Pi by 2 root 2. This is what you have to prove. Hence proved. So very simple. You are just using only one formula. Both look same, exactly the same. Gamma of n by 2. Same formula only we are using. But you are comparing the terms. In this first term, in the place of 2n minus 1, I have got 1 by 2. In the second term, as minus 1 by 2, because this is power 1 by 2 here. Here, if it comes to the numerator, power minus 1 by 2. So, if you multiply these two, we are getting the desired result. And whichever formula is applicable, use that. For example, if my question is integral 0 to infinity, x power 3 by 2, e power minus x dx. Now for this, which formula I will use? First formula. Remember I wrote gamma of n is integral 0 to infinity e power minus x, x power n minus 1 dx. Because what power we have? E power minus x. If the power matches, then in the place of n minus 1, what I have? 3 by 2. So, n minus 1 is 3 by 2, which implies what is n? 3 by 2 plus 1, which is 5 by 2. So, your question is nothing but gamma 5 by 2. That's it. Direct formula we are using. Now, to find gamma 5 by 2, we are going to repeatedly using the formula gamma of n plus 1 is equal to n into gamma of n. So, gamma 5 by 2, how I will write? Something plus 1 I have to write. So, what is that something? 3 by 2 plus 1. So, if n is there, then I will write n into gamma of n. Same thing. So, 3 by 2 into gamma of 3 by 2. Then this 3 by 2 again I will split. Gamma of 1 by 2 plus 1. So, now how I will write? Again I am repeating the same formula. 3 by 2 into 1 by 2 into gamma of 1 by 2. So, gamma of 1 by 2 is nothing but root pi. 3 by 2 into 1 by 2 into root pi. So, your answer is 3 root pi by 4. So, you are going to use the basic formulas. What is that? Gamma of 1 is 1. Gamma of 1 by 2 is root pi. Gamma of 1 by 4 into gamma of 3 by 4 is pi root 2. All these things. Gamma of n plus 1 is equal to n. So beta gamma function is full of formulas. We have to just use the suitable formula, the suitable place. So your first question, we have used the first part of version of gamma of n. Okay. And in one more question, you have used the second version of gamma of n. See here, this is first version which we use now. And this is the second version. So whichever suits the question, depending on that, you have to substitute. And one more thing, keep in mind, gamma of 5 by 2 you got like this. For example, if they ask you gamma of 7 by 2, directly you can write 7 by 2 minus 1, 5 by 2. 5 by 2 minus 1, 3 by 2. 3 by 2 minus 1, 1 by 2. Once you reach 1 by 2, you write gamma of 1 by 2. Actually, this is what we did. If you see here, gamma of 5 by 2. 5 by 2 minus 1, 3 by 2. 3 by 2 minus 1, 1 by 2. Once you reach, here it is. Once you reach 1 by 2, write gamma of 1 by 2 over. So, within bracket, you write using gamma of n plus 1 is equal to n into gamma of n. Similarly, if you get a negative power, okay, for example, if they ask you to find gamma of a negative value, say gamma of minus 7 by 2. So here I cannot use that this is something plus 1. So here same formula only, slightly I am twisting it. Gamma of n plus 1 is n into gamma of n, which implies gamma of n is gamma of n plus 1 by n. So this version of the formula we are going to use if this is a negative value. Okay. So keep this in mind. For negative fraction we are going to use this. So in the place of n, what I have? Minus 7 by 2. So gamma of minus 7 by 2 is gamma of minus 7 by 2 plus 1 by minus 7 by 2. So now it is reducing, you can see. Minus 7 by 2 plus 1 is nothing but gamma of minus 5 by 2. So let it be minus 7 by 2 is there in the denominator. Again you are going to use this formula. So how I will write? Gamma of minus 5 by 2 plus 1 by minus 5 by 2. Already the 7 by 2 is there. So again I am writing this existing value. So minus 5 by 2 plus 1 is nothing but minus 3 by 2. So this minus and this minus will become plus 7 into 5 by 4. Okay. So now again you can keep this as n. Again you are using the formula, what is gamma of n? Gamma of n plus 1 by n. So I am writing minus 3 by 2 plus 1 by minus 3 by 2. Already what you have? 7 into 5 by 4 is there already. So this becomes gamma of minus 1 by 2. Okay. By minus 3 into 7 into 5 by 8. So again we are using the same formula. This one, in the place of n we have now minus 1 by 2. So gamma of minus 1 by 2 plus 1 by minus 1 by 2. So already we have minus 3 into 7 into 5 by 8. Finally, what is this value? It becomes plus gamma of 1 by 2. Okay. And the denominator all will become positive. Right. So 3 into 7 into 5 into 1. That is there. And the denominator 8 2s are 16 will jump to the numerator. Gamma of 1 by 2 is just nothing but root pi divided by 3 into 7 into 5, which is nothing but 16 by 105 root pi. This is how you have to find the value for a negative fraction. This is how you will find the value for a positive fraction. And simple, if it is gamma of 5, then you can write 4 factorial. Why? One more property I said, gamma of n plus 1 is equal to n factorial if n is a positive integer. So this 5 I will write it as 4 plus 1, which is nothing but 4 factorial. Thank you.